University of Genoa is the leading partner of the project PROMPT, which is focused on the preparedness against contaminant dispersion in sea and waters in harbor environments. The project continues works and activities developed in another project funded by the DG ECO program from the European Union. The previous project was called Be Ready. And in this project, basically, we extended the capabilities and the analysis to new applications like oil spill detection from satellite images and container detection from, again, satellite images. On the other side, we are developing hazard and risk modeling for contaminant dispersion for the harbor of Genoa, and we add the new ingredients to the dispersion analysis of contaminants, take into account the atmospheric dispersion of the volatile part of the hazardous material and oil spill that we can find in harbor waters and that can separate from the liquid phase and disperse in the atmosphere. University of Genoa is developing the numerical models, and the results of the numerical models of the dispersion of the contaminants will put together with the decision support system developed by IAC Cantabria in order to prevent ocean contamination and ocean pollution. This tool works on the basis of offline forecast, which is a technique that has been developed by our research group. We run offline a set of climatic conditions that has been selected on a long database of history of metocean conditions, information about wind, ocean currents, waves. So we develop an algorithm which compares the forecast with those scenarios. We can identify which scenario is the closest to the future forecast. And so the managing authority can have an insight, if it happens an accident, of the dynamic of the dispersion in the next future. We use these objects that are called drifters because we just put them in the water, we launch them in the water from a boat, and then they have a tracking device inside, and so they give their position in time for a long time, like a few days. So then we collect the information, and we can compare the information coming from the drifters with the simulation that we did. And so we can validate our model, so we can give a rate of reliability of our model.
WASD is a startup in Luxembourg, and it is based around a platform, a cloud platform that helps remote sensing experts turn their algorithms into applications in the cloud that can then be used to address real-world problems. In the context of the PROMPT project, we have two tasks. The first one is mapping oil spills, and the second one is detecting floating containers. Let's discuss how to map oil spills. We are using an approach developed by our partners, the Luxembourg Institute of Science and Technology, which exploits Sentinel-1 data. So the instrument sends a signal towards the surface of the sea, and the sea tends to be slightly rough. But if there is an oil spill, then that area becomes smoother and the signal from the satellite gets reflected away, so no signal returns to the satellite. What that means is that looking at these satellite radar images, the oil spills are black, very dark, so they can be more easily segmented. So that's the general idea, the general concept that we are using here. Let's discuss the problem of detecting containers. First of all, it's a cost. Second, it's an environmental problem because they often contain polluting substances. Third, it's a hazard for navigation. If they're not detected in time, an accident can occur, which can be fatal, maybe especially for smaller ships, but not only. Unfortunately, it's not possible to detect them using publicly available imagery. Some of them might appear like 1 pixel in an image. So we are planning to do an experiment in the port of Tripoli in Lebanon. Our partners are going to float a couple of containers, and we are going to task the acquisition of a very high resolution commercial imagery over the period of the experiment in order to build a data set on top of which we have some ideas on how to detect these containers. Basically, we are going to try a couple of big families of approach. The first approach will be traditional statistical methods. We're going to exploit the fact that the containers have a different color from the sea. The second family is the AI-based family. These techniques keep evolving very quickly, I would say on a daily basis, and we now have general purpose models that can be used in detection and segmentation tasks, such as this one. And then we may be willing, if necessary, to do some fine-tuning and see if we can improve the performance of these models.
In the PROMPT project, IH Cantabria is involved in different tasks. The first one is implementation of the numerical model for oil and chemical spills in the marine environment and the development of the risk assessment methodology. The risk methodology is based on the combination of the hazard and vulnerability, and is estimated taking into account different indexes for example, economic, ecological, or human issues. The second task is the development of the decision support system for PROMPT. All the information generated with the numerical models and the risk assessment is integrated in the DSS. The DSS is made up of two different modules. The first one, the operational forecast module, to simulate, in case of an accident, the forecast of the transport trajectory and dispersion of the oil or the chemical spilled. The second module is the risk assessment module, which provides a probability, vulnerability, and risk maps for the marine and the atmospheric pollution. This information is very useful for improving planning and preparedness. Finally, IH Cantabria is also involved in the training on the use of the tools and the risk assessment maps, obtaining the framework of the project.
Our main duty in this project as Port of Tripoli is to track lost containers. So we will through two containers. The first is blue, the second is red. In Port of Tripoli, we have main breakwater and secondary breakwater. The distance between these two breakwater is 237 meters, which is the navigation channels. So between these two breakwater, vessels can enter through this navigation channel. So our experiment will take place close to the secondary breakwater. The same will be done for the second container. It will be more than 100 meters away from the first. All the steps of the experiment were done successfully. Cristiano couldn't get high resolution for the images, so he aimed to get more high resolution, but he couldn't at the end, unfortunately.
So in Jordan, as a pilot's area in Gulf Aqaba, we apply the very, very strong, actually, a model that can really give you a prediction how the spill will flow with the currents. So what's our role in this PROMPT? The second one is to enhance this software by having more boundary conditions that measured really, or having a real measurements, will provide the model for more accuracy and good resolution to estimate or to predict the oil spill around the Gulf Aqaba, for example. We know that the oil spills mostly remains for hours or day, and then it's converted to another chemical compounds. So the idea for prevent or to trying to facing or to solve any oil spills is in the first few hours. After that, it will be a reversible process. So we need to have action. There is no time to wait and think too much. And we know that the most difficult is to predict the water, how it moves in the ocean. It's a fluid, and the fluid has many characteristics. It's incompressible, and it's really randomly sometime moved, but of course based on the external or driven forces. So we're trying to controlling all these the driven forces, that the wind and the current itself, that depend in different factors. But since we have current meter for as long as possible information, so we can have an idea how this water current is moved seasonally. Meteorological conditions is easier to predict, and we can combine these all external forces to build up this model with the initial and boundary conditions.
When you talk about oil, you have an atmospheric part which has to be studied and considered. And that's our role. We talked about the atmospheric impact that you have when some accident happens in the airborne area. So, what does it happen when an accident becomes? The decisor can use the prompt tool and understand which is the best intervention to be adopted to mitigate the impact, both in the marine environment and the atmospheric environment.
ERI is responsible for communication, dissemination, and capitalization plan. So we make sure that the project activities, results, and impact are being disseminated to the right stakeholder. So basically, we have three fundamental activities that we are responsible as far as work package 2 is concerned. They are the project establishing or developing the project identity and enhancing visibility, which is under that activities we develop the logo of the project, but also we provided some kind of promotional materials, and also under that activity we created what we call some social media profile like Facebook, like Instagram, but most importantly we leverage also the side of the UCPM, which is the Union Civil Protection Network platform, which was dedicated by the project, anyway, by the EU, basically, to make sure that all the project result activities are being disseminated there.
Each one of these projects is a ring in a long chain. If there is any kind of accidents, these kind of projects are very, very important to get more experience, to be ready, to have high response to the accident, and especially the environmental ones.